looking for the ones who missed the class or wanted a thorough explanation, here is our problem, which will be on Sakai. I'll upload it on Sakai, and I will skip the modeling part. You can see it. You can observe what comes from where, etc. So we have three decision variables. Actually, this was a problem to maximize the profit by planting tomatoes, onions, and peppers. And x1 is the number of acres dedicated to tomatoes, x2 for onions, and x3 for peppers. And the mathematical model is just how much profit we gain from them. So 1 acre of tomatoes makes us gain $20,000 and so on. So you can see the objective function here. The first constraint is a water constraint. The water in the fields or plantations are limited, and we have only 2,000 tons of water for the whole field, and these are the water requirements for tomatoes, onions, and peppers. The second constraint is a worker constraint. We have 70 people working, and these are the worker requirements for tomatoes, onions, and peppers. And this is the land constraint. We have 30 acres of land, so our planted vegetables won't exceed 30 acres. And here's our non-negativity constraint. So what we will do now is to code it in. First, Lindo. Lindo is a very direct, very straightforward software to use. It has a screen or an interface like this. It runs on Excel, so you cannot directly run it on Mac. You have to download a software which enables you to use Windows software. So I'm using Wine here. Using this Wine software, I can open exe files for Lindo. So what I do is, here's my model, and let's take Lindo below here. Write directly the objective function first. So I start with a max or min. Here is my problem, which is a maximization problem. So I start with a max. I don't write z or anything else. I just write the objective function as it is, actually. Nothing more. So this is it. This is my objective function, and I don't have to define my decision variables. So Lindo automatically sees this x1 and knows it to be a decision variable. Like this is also valid for x2 and x3. So it sees the variable, it knows it's a decision variable. So I don't need to define anything. Once writing of the objective function is over, I will pass on to the constraints, and I will tell Lindo that it has to pass on to the constraints. So I'm writing st, which is short for subject to, as you all know. So after st, I can write my constraints, and st states that the objective function is over. So my first constraint is here. Voila, this is the first constraint. And this is the second constraint. As you can see, it's really straightforward. It's really easy. 2000, sorry, 70. And x1 plus x2 plus x3 is less than or equal to 30. I don't need to write non-negativity constraints here. Lindo, by default, assumes that your variables are non-negative. Now, the thing is, we generally put an end to Lindo when the code is over, but you don't need to write that. You just say, press on the dart button here, and it says do range or sensitivity analysis. Right now you don't know it, but soon you will need it, so I'm clicking yes, and I'm closing it, and here's my Lindo. I'm passing to the screen below. Oh, here it says LP optimum found at step 0. Actually, it should have been 1 because it did just one iteration to pass on to there. And the value of the objective function is 600,000. The optimum value of x1 is 30, and the optimal value of x2 and x3 is 0. Here, in the slack and surplus part, you can see the constraints here. Row 1 is the objective function row. It's like row 0, but Lindo doesn't have row 0. It starts with row 1 here. So the first row is the objective function, the second, third, and so on are the rows that belong to the constraints. This is my first constraint, which is specified as number 2, which says the slack or surplus is 500, which means the value of S1 is 500. You remember the S1 in the standard form, that's the value of the slack variable of the related constraint. As the second constraint, the value of the slack variable, which is S2, is 10. And for the third constraint, the slack variable value is 0. So you can see that the basic variables are x1, s1, and s2, and the non-basic variables are x2, x3, and s3. So it says number of iterations 0. I don't know, it says that it should say 1 at least, but it's a problem with my software. If I run it again, or if I use n here, okay, 0 iterations, okay, that's fine. It means I'll have to just add 1 iteration to know at how many iterations Lindo solved this problem. Then, one last thing, it's not about utility now, it's about some appearance. Let's just say I want to remember what constraints were about what. So this was, for example, water constraint. I just write water and use a parentheses sign here, like I'm closing a parentheses here. So in this way, I name the constraint. So this is worker constraint. And this is land constraint. So when I run this, here you can see which constraint is used and which constraint is not used. This means I'm totally using the land constraint, but I'm not totally using the worker and the water constraint. So this is how Lindo goes.